Welcome to myprojectbazaar.com. Now we can going to discuss about the product 5 level transformerless inverter for single phase solar photovoltaic applications. Now we can going to discuss about the abstract of our project. This system for main advantage of process is transformerless. So we can economic wise our system as very efficient. So we can very remove of transformerless inverter. This is mainly for our economic is a very improvement of our economic level. In case our transformerless inverters are extremely employed in grid connected photovoltaic generation systems due to advantage of achieving low cost and high efficiency systems. The low cost means our system has an efficient to usage of low cost because of we can without transformer. However, the common mode of voltage issues have been motivated the and proportional of the integration something. So solar PV modulations is a great integral process of the direct connected the negative pole of the DC bus. So therefore DC bus activation of the main important process of this process. Therefore plasmatic capacitors are bypassed mode and leakage current can be eliminated. So one of the advantage of this process and leakage current also eliminated and harmonics also very reduced. In this process 5 level common grounded transformerless inverter with reduce the output harmonics content of solar panel is produced. In additional proposed inverter can process the reactive power and its presence the maximum DC voltage utilize the opposing of the half bridge based on topology rectifications. In this different mode of operations proposed inverter can simple modulation strategy as well as design the guidelines of analysis detailed. Finally, experimental results are demonstrated to the proposed system and some simulations also perform the feasible for good performance will given to the our inverter levels. Next we can going to discuss about the flow diagram of our product. First we can see about the irradiance level. Irradiance is nothing but to input getting this solar panel of the in generating this our sun. So we can input of our solar panels different levels of irradiance level will given. For example, our process will take the our 1000 irradiance level is processed to the solar panel. This, our solar panel has 6 panels using the 36 cells. We can use the individual cells for this panel. Totally we can show the entire solar panel we can use the 72 cells. The 72 cells is generating the voltage and current is processed to the maximum power point tracking technique. This tracking technique we can improve our power and improve our voltage stability also. So this is process maximum power point tracking passed to the boost converter. This boost converter to improve our own again we can step up of the another level of solar panel. Example we can generating our solar panel of 12 kilowatts. We can improve our whatever we can 80 kilowatt or 16 kilowatt to improve our power. This improved power is passed to the DC to AC multi-level inverter. This DC to LT multi-level inverter is a very important role of this process because of lot of existing system we can use the DC to AC inverters. These inverters are of maximum of losses and noises created this, but we can use DC to AC multi-level inverter of 5 level. So some noise reduced and the system balance to improve our system, so and improve our voltage stability also. So we can given switching pulse also very important one of this process. So given switching pulse of some controllers will given to operate that switching pulses. It's not for using for PWM or PI controller and sign PWM or space WMs and nothing else we can use the in this process. Again this pulses given to the DC to AC multi-level inverter we can use for 5 level multi-level inverter. This 5 level multi-level inverter is generating for AC in the output. The output is then stored the grid. The grid is used for number of lines connected in single. We can use the one of the this is also generation like for generation means you can use a thermal power plant or nuclear power plant. Whatever we can use that. You can also act as a battery also. Once we can use the energy stored or energy utilize this grid. Next we can going to discuss about the running procedure of project and proposed system implementation done in MATLAB version 2013A. First you open the MATLAB window and create a new model file and creating elements as per the circuit diagram of the project in the of our base paper, and the connecting elements as per the corresponding scope are connected in the lines. I will show the main modeling block. These are our modeling blocks. The corresponding code from the from two functions can use that functions. These are solar panel and 5 level inverter levels and given to switching pulse, and this is an upgrade and some whatever switching pulse. Some analysis functions we can use that we can running that. The model is running. And the running process is done. I can show the RSLs for this is on our solar panel output for PV characteristics. Y axis is on power, x axis on voltage. This is on perfect curve for that PV characteristics. Next we can see the IV characteristics of solar panel. This is on x axis is on voltage, y axis is on current. We can this is curve also IV characteristics. This performance for the solar panel. Next we can going to shown for this and grid voltage is perfectly we will getting store of energy for a 100 amplitude range to perfectly sinusoidal wave. Next we can discuss this is on triggering pulse. This is an triggering pulse of the process. We can triggering pulses to the our DC to DC boost converter. We can trigger these levels to input of the MPPT, and is passed to the IGBT switch to trigger on the pulse, and some saturation will given to this triggering pulses. This is a saturation result and triggering pulses. This is an VDC for solar panel. VDC means for our boosted output. Our boosted output is nearly 350 voltage. Our input of solar panel is for only for 45 or 49 difference in range, but we can generating our total output for 350 amplitude in voltage. It's a continuously DC power. This is for simulation results for grid connected inverter. This is for current and this is for voltage. This is the current is given for sinusoidal, but voltage is getting to the purely DC. See that we can a lot of fluctuation waves in this voltage curve. Next we can see the switching pulse. This is our switching pulse of the different 5 level switches. We have 6 switches, but we can convert rack as 5 level. The situation I can see for some repetitive sequence. We can sawtooth wave like sawtooth waves and randomly our duty cycle is very linear and different range to on and turn on and turn off the process. Suddenly it's turn on and suddenly turn off. This is continuously process to it. And number 2 switch is on. Sometimes it will goes to on and again we can off, and some sequence wave will return as. We can see that we can some invest to the voltage. Again we can switch 4 and switch 5 and switch 6 are switch 6 is similar to is an step on and step off of the process. Some variation to the our switching pulses. This is our overall process of the results.